We've made it to the final video of the week. Okay. This time, we're not going to have a picture of a function. We're not going to have the ability to use geometry to find area. But what we do have is we do have a list of certain integral information that is given to us. Something. I don't know what the heck was happening with my screen. Here is the information that is given to us. All right. We're going to be able to use that, mix it up in certain ways, and hopefully we can evaluate some of these integrals. So we got the first integral is negative 2 to 5 of f plus g. Well, we're going to use the property that says we can split those apart. So that problem, we're going to say that is the integral, right here below. So negative 2 to 5 of f of x dx plus negative 2 to 5 of g. And then we just have to access that information. So that's given as 18, and then that's given as 5. So 18 plus 5 is 23. So that part is 23. Next one, that is a bunch of things added, so that can be split apart. So 23 would be the definite integral from negative 2 to 5 of f. I'm going to write these shorthand. You know what? Yeah. Plus the definite integral from negative 2 to 5 of g, plus the definite, minus, my bad, negative 2 to 5 of h. So those are given as 18 and 5 and negative 11. So 23 plus 11, that one's going to be 34. So next one, you've got the definite integral from 5 to negative 2. Well, we're not given that one. So we got to think about flipping the limits there. So negative 2 to 5 of 4 times g of x dx. And we've got a constant multiplier which can be factored out. So that 4 is getting factored out. And now we have the definite integral from negative 2 to 5 of g, which is given as 5. So negative 4 times 5, that value is negative 20. Okay, 25. That is like a vertical shift on the graph of g. And it's actually a sum of functions. So by the properties, we can break that apart. Break it. So negative 2 to 5 of g of x dx plus the definite integral from negative 2 to 5 of 2 dx. Negative 2 to 5 of g is given as 5. And then the definite integral of a constant, remember, is a rectangle that has a height of 2 and a base of 7. So that has a definite integral of 14 because we were integrating to the right and the function was above. So that's going to be a positive value. So grand total is 19. I don't want to see any of this. Warning, don't be doing this. Negative 2 to 5 of g of x dx plus 2. No. If you're breaking up a definite integral, break it up in 2 definite integrals. Don't just cut off the 2. That ain't how you do it. Okay, that's not the property. So 20, that's a common mistake that a lot of people make. Don't you make it. Okay, 26. We want to break that one up. Again, that's another vertical shift. So negative 2 to 5 of f of x dx minus the definite integral from negative 2 to 5, 6 dx. Negative 2 to 5 is given as 18. This is the integral of a constant, so it's another rectangle that is 6 in height by 7, so 6 times 42. We got minus 42 there. So 18 minus 42 is zippity zappity 24. Negative 24. 27. Oh, whoa, what is happening here? We got the integral from 0 to 7 of h of x minus 2. So if you know a thing or two about function transformation, the previous two examples, 25 and 26, were vertical shifts, right? We've added a value to f. Here, we've subtracted a value from x. So h of x minus 2 is actually a shift of h horizontally, not vertically. That's not h of x minus 2, that's h of x minus 2. So what that means is that we have taken regular old h and shifted it to the right. So in order to shift ourselves back to regular h world, we can actually shift ourselves back to regular h world because the horizontal shift doesn't change the function at all other than just where it is right and left. It doesn't change any of the area underneath or the values of the definite integrals. It just changes where they happen on the x-axis. So we can shift back to regular h world if we think about what are the values in regular h world that correspond to h of x minus 2. Let's see. At 0 in h of x minus 2 land, that's the same as h of negative 2, isn't it? Like if you sub in 0, it's the same as h of negative 2. So that's the same here as negative 2 as my lower limit. And then back in shifted world, if the x value is 7, if you sub that in, it's the same as h of 5. So and the unshifted h, that's the same as the integral from negative 2 to 5, which we're given. We're given that information. That's negative 11. So that was a horizontal shift as opposed to a vertical shift. Check it out. Happens in 28 as well. So g of x plus 2, we can convert that back to regular g of x by shifting the x values, shifting the limits. So the limits, really, we can just see what happens at negative 4. You put negative 4 in there, it's the same as g of negative 2. And at 3, it's the same as g of 5. So back in unshifted g world, it's negative 2 to 5, and that is provided to us. The value is 5. So the integral from 5 to 8, we don't have anything that's from 5 to 8. So how can we unpack 5 to 8? Let's see. Oh, I got it. How about this? How about 5 to negative 2 of f of x dx plus the integral from negative 2 to 8. That would indeed be the integral from 5 to 8, according to the property. So I picked these on purpose because I know something about negative 2 to 5 and negative 2 to 8. So that first one there, 5 to negative 2, I can actually flip the limits and flip the sign. That would be negative 2 to 5. And that is given as 18. So we got negative 18 plus negative 2 to 0, or I'm sorry, negative 2 to 8, which is 0. So that's negative 18. Last but not least, we're going to package a bunch of different things together. So get ready. This is it. First thing I see there is a sum of two functions, f and plus 3. So I'm going to split those apart. So 1 to 8 of f of x minus 3 dx plus integral from 1 to 8 of 3 dx. Now 1 to 8 of 3 dx, just a rectangle, height of 3, base of 7. The value is going to be 21. And then f of x minus 3, that's a horizontal shift of f. So we need to shift it back where it belongs. by subbing in those values. 1, let's see, at 1, it would be the same as f of negative 2. If we subbed in 8, it'd be the same information as f of 5 in regular f of x world. And we know that that value is 18. It's provided, so 18 and 21 make 39. That's how you take care of those problems, applying the properties of definite integrals. Hope you guys enjoyed. I'll see you next week. We're going to be working through some fun problems. Okay? Peace.